guys had with colored pens? Switch. You already tried. You tried. That was the pencil. Let's get to your color pens. Remember that way you can look back and say, what didn't I get? The name of the game of number 114 was Translate. Ooh. What did you guys write down as the most important information of 114? Function. Super important, right? What else? Twice. Is twice. That's important. What is twice? The rate of change at x equals c, the rate of change of f at x equals c, and? Okay. What different rates of change did, we had a forever card yesterday, right? Some of you got it down, some of you didn't. Some of you still need to take a picture of it and get it in your notes. This is a super important forever card. Looking at this forever card, question, what are the two different types of rates of change that we can solve for? Change of position, of velocity, of acceleration. We could do all sorts of different rates of change of different functions. But what are the two different types of rates? Average or instantaneous? Average, how many times do I need? 2. Has to be a change in position over a change in time. I need 2 times. Instantaneous, I only need 1 instant. Remember instant mac and cheese? Instant oatmeal? Isn't really instant, it's more average. That's funny. Anyway, coming back. 1 time. So question, what are we doing for these guys if it says the rate of change of f at x equals c? How many times is that? Careful. Your brain sees this, you're like, 2. The rate of change of f at c is twice. How many instants are there? How many times are there? For this side, because is twice, guys, you know this, is twice, right? Is 2 times. What is twice something else? The rate of change at 1, just at x equals c. So is this an instantaneous rate of change it's talking about, or an average rate of change? F prime of c. The instantaneous rate of change of a function f at x equals c is 2 times what? F prime of... Yes. Does it make sense, though? If it says the rate of change at 1 time, that's instantaneous. An instantaneous rate of change is the definition of, the description of... Yeah. Where are the rest of you? Wakey, wakey. Okay, of the derivative, right? Now, how do we actually solve? AP loves forcing you guys to get some sort of little formula, some sort of little expression, some sort of like, hey, solve me, but you have to go back to actually do it. How do we solve this? We have to go back. So f prime of x. Can you guys double check John's work, I should say, 5/4 x to the negative 1/2. Do you guys agree? Because what power is a square root? Bring down the half. A half times 5 halves is 5/4. Yeah, it makes sense. And a half minus 2 halves is... How are we doing on the mental math power rule? Little by little? Now, does your brain think with negative 1/2 powers? Mine doesn't. So how could we rewrite this to make it a little bit easier? Yeah, make it a fraction. So what's going to join the 4 in the denominator? Square root of x. Do we have to rationalize? Nah, it's calculus. Ain't nobody got time for that. So, coming back, what am I going to plug in this spot? The 5/4. Good. Square root of who? Technically c. Technically, right? So it says at x equals c, so we plug it in, plug it in. Who's over here? Good. 5/4. It's as easy as that. The instantaneous rate of change at c is twice the instantaneous rate of change of 3. Cool. Who's the instantaneous rate of change? This guy, the derivative. Plug in, let's solve. For who? Now, be honest with me, just because I need to know where you guys are at. This is like a real moment, okay? Be real. I don't like the looks of that. Like, I'm a little afraid I'll get it wrong. Okay, like half the class. Okay. So let's walk through step by step real fast. There's a lot of numbers, a lot of square roots. The C is way down here. I did it really fast in period 1, and maybe that was a little unfair. What would you guys think of doing? Multiply by 2? You don't want to do that. Multiply by 4? We could do that. Did you say something else, Kevin? 4? Okay, we could do that. What we do to one side, we do to the other. Does anybody else like getting rid of division? Didn't I tell you guys that a lot last year? Get rid of the division, get rid of the division, get rid of the division. So now I have 5 is equal to, 2 times 5 is 10, 10 times 4 is 40. Oh, don't the 4's just go away? Oh, 10 root C over root 3. Now what? You could. I don't know if that's the easiest. Yeah. I would get rid of all the division you can. Now careful. Do any illegal math. Does that 5 get to join 3 and be a 15? No. He does not have a radical. Good. Now what? You could. I wouldn't. Oh, you could divide by 5. Eventually you have to get the C alone. How many of you guys would think square? How many of you guys would think divide by 10 or divide by 5 or divide by something? Okay. More people want to divide. I'm going to divide by 10 just because aren't we supposed to be getting the C alone? I think that one makes a little more sense. And we end up with, that reduces 1 over 2. Root 3 over 2 equals root C. Eventually, John's right, we do have to undo that square root with a squared. And we end up with C equals 3. Please be there, please be there, please be there, and please not have none of these. Dun, 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 dun. How many people solved and got 3/4? How many people guessed 3/4? All of them would have gotten it right on the AP, technically, right? But hopefully our understanding will get deeper than guessing. But they would have gotten it right. But do you know how you could now get it right? Number 114. The key was, can you translate? And then, can you go find a derivative, plug it in, and solve the algebra mess that ensues? Ooh, ensues. Good word. Number 115. This was the one, percentage-wise, that our class thought was the easiest. Why? It's finding the derivative with basic rules, right? Except there is one little thing that could mess people up. Anybody know what the one little thing could be? Maybe the 6 in front of the E. I didn't expect that one, though. I was thinking the pi and the 4. Because to be honest, I would have rewritten this first. In my head, I wouldn't probably have taken the time to do it on paper. But I would have wanted you guys to think of the rewritten form. Why was I allowed to pull the 4 out with the pi? If I divide by 4, what am I multiplying by? If I cut a pizza in 4s, I'm multiplying by 1/4, right? Dividing by 4, multiplying by 1/4. So can't I just pull the 4 out and make him part of the constant multiple? Oh, sweet. Then the derivative is easy, because then y prime or dy dx, however you write it, what do I do with the 6? Leave him. He's a constant. What do I do with the e to the x? Derive him. It's e to the x. What do I do with the pi over 4? Leave it. And what do I do with the sign? Derive it. Is there an answer that matches that? Yes, indeed there is. My question to you is the following. What mistake would have been made if someone would have chosen A? What mistake would have been made? Yeah, what rule did they think, or could they have thought? But why is the power rule illegal to use for this guy? Yeah, first it's an e to the x, and we have a rule for that. That's really true. But also power rule. When we talk about x to the n, real quick, who's the variable in this expression? Ah, that's your variable? Who's this guy? Can I apply the power rule, which applies to a variable to a constant to a constant to a variable? Does that even make sense? Totally different guy. He's exponential, whereas this guy is a power. Power, exponential, two different guys behaving very differently. He has his own rule. Dun, 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 dun. 116. How many of you guys got 115 right? Solving it. How many of you guys guessed it? You would have gotten it right too. Just careful. Maybe not every time. Number 116. Section 22B, the position. Oh no, it's some of those motion-y ones. Okay. Do you think this equation is important? Yeah, me too. Where S is meters, T is time, measured in, what is it, seconds? Okay, I just crossed that out. I didn't mean to. What's being asked for? Average velocity. Man, there should be a formula for that. Oh, thank you. Uh-oh. Uh-oh. Wait, this isn't mine. Hold on. Where'd he go? He just walked out the door. I'm guessing if there's something by David Sheffield about Faulkner, that probably would be Mrs. Ranieri, right? It's definitely not me. Does that look familiar? This is mine. Is she doing Faulkner right now?
I think this might be it.
Okay, perfect. Thanks. 116, average velocity. What is the formula for average velocity? Thank you, Lainey. Yep. Why am I plugging in 2 pi and why am I plugging in 0? Good, that's exactly what they gave me for my interval. But Abby, you were saying position over, what was she saying? She was right, too. Kind of. What's the little formula that comes before S of B minus S of A all over B minus A? Change in over change in time. Change in position over change in time. Miles per hour, feet per second. Change in position over change in time. So change in, subtraction, S of B minus S of A. Over change in time, subtraction, B minus A. Here's a dilemma, kiddos. Look at those multiple choice answers. If you ever have a practice multiple choice problem from me, you should be able to look at the answers and know whether or not you would be allowed to use your calculator, calculadora, calculatrice. Would this be a calculator or a non-calculator problem? Non-calculator all day long, because what is not here? Decimals. They're not there. So how do you do this by hand? Plug it in, unit circle. It's okay, you can whine, you can complain, but you have to find it. So S of B would be 2 cosine of 2 pi plus sine of 2 pi plus 2 pi over pi plus 4. It's okay, complain, but keep going. Or not complain, that's even better. Yeah, Abby. Oh, did I not finish my pi? Thank you. Minus cosine of 0 plus sine of 0 plus 0 over pi plus 4 all over 2 pi. Hey, I think the angle 2 pi is kind of important. What do you guys think? Unit circle. Isn't 2 pi at 0? 0 and 2 pi are the same thing? Isn't sine 1 and cosine 0? So isn't sine going to be 1? Isn't sine going to be 1? Wait, who's who? Sine is 0. Careful. If you plugged in your circle wrong, guess all of this nice work. Exactly. Sine is 0. Cosine is 1. What else do I have? Oh, pi over pi, that reduces. That's 2, and that's 4. Minus. Cosine is 1 times 2 plus sine is 0 plus 0 plus 4. What do we get? 2 plus 2 is 4. 4 plus 4 is 8. We have 8 minus... Dun, 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 B. Who got B right solving it? Who got B right guessing it?
She said hold on first.
Oh, she must be telling me something about it. Okay. Missed it.
job. I just guessed. Sorry.
Okay. Let me ask again now that we've graded it. How many of you guys think, if I'm asking which one was the hardest, like now seeing the work, having gone through it, how many of you guys still say 114 was the hardest? How many of you guys say 115 was the hardest? How many of you guys say 116 was the hardest? Okay. We had a couple change to 114 from 116, but still, these two were predominantly harder for most people than that one. But the over 4, it does get a little bit confusing. Okay, my question is not, did you do it perfectly the first time when you had time to do it? The question is, do you think it's possible for you to get it right the next time if you see something like it? Cool. Questions, though? Anything that didn't make sense? Okay. Hey guys, in AP Calculus, I think the goal is to see as many questions as possible and memorize them all and then be ready when they show up on a test? Or is it to see as many questions as possible, find the patterns behind them, and know how to deal with the patterns? Oh. Is that a little bit of a struggle compared to some other APs? Maybe. Some other APs is like just memorize, 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 memorize. Not all. AP Psych is kind of like that. APUSH is kind of like that. AP Gov is kind of like that. But are some APs, like you actually have to work things out on your own based on these foundational ideas that you're supposed to be learning and practicing and understanding? That's like an AP Calc, that's like an AP Chem, that's like an AP Bio, that's like a, ooh, you got to use your brains. But, here's my question to you before we leave this for today, are there any key phrases or wordings in here that you guys need to make a note of so that you don't forget for later? Like, for instance, average velocity, was that important? Yes. Did it lead to a very specific formula? In a forever, there he is, in a forever card? Yes. And was there something that actually went back a long time ago to translating? Kind of, but isn't this a new thing? The rate of change of f at x equals c? Maybe some of you guys need to highlight that one and be like, ooh, I need to keep an eye out for him. I need to keep an eye out for him. Is that in the forever card? No. We don't write instantaneous rate of change in a forever card. Maybe we should. It's not the definition. It's just a description. But some of you need to attach those two ideas together. All right, cool kids, homework. How many of you, before we've graded any part of homework, already know they need some clarification or questions answered, at least one? Yeah. All right. All right. I have my book open. Sadly, this guy is still not working for today. We tried real hard. Didn't work. So instead, I have my little cursor open with some white space. If you guys have any questions that come up, but we're going to go ahead and grade the evens, okay? So grading the evens, number 92. It was having you do average and instantaneous, right? I wouldn't. What do you think I would say the best answer is? Square root of 3 over 2 and 3 over pi. If the multiple choice did have decimals, I suppose that these could have been ones you used your calculator for. By hand one. Don't stop with the decimals, or don't go to the decimals. Stop here. Exact answer, done. Exact answer, done. Dun, 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 dun. Got it. Number 96. Sorry. Instantaneous average in case you're still looking. Was 96 easy? Not really. There were two questions being asked in number 96. One of them was the velocity after 3 seconds. PS, that's this guy right here. That's one answer, negative 118 feet per second. And the other answer was how fast it was going when it passed, when it dropped 108, after it fell 108 feet. The first answer is negative 118 feet per second. The second answer is negative 86 feet per second. We'll come back to it. Number 98. The initial position, how tall was this object thrown from? Was it being thrown? Oh, dropped. It was being dropped from a cliff or a building or atop a building. That was 153.7 meters approximately. Although I hate one decimal place. There should be 3 of these. I think it's 153.664. Okay, cool. Thanks, David. Then last but not least, we have the graph of the derivative. But I'm pretty sure we just zoomed past some of your questions. Want to go back to number 96? Okay. as we go back to number 96, let's talk about why all of this stuff is what it is. Let's talk about why it is what it is. What's the given information in number 96? Is thrown down? Okay, so the ball, let's just say, Joseph, just to make it super clear, we'll say the arm is extended out and being thrown straight down. Okay? Straight down from the top of the building. Not the top as in like I'm going to hit the building, but the top as in I'm leaning over and not falling off. Okay. So the ball being thrown straight down. And how tall is the building?
220 feet.
Okay. So this is 220 feet. With an initial velocity, does it say how fast it's being thrown?
Negative 22 feet per second.
Whoa, do you guys see what I just labeled the initial velocity with? V sub 0 or V of 0. I could have also said V of 0, but there is a shortcut way of writing V of 0, aka the initial velocity. It's this little guy called V sub naught. Subscript, sub, naught, well, I don't know, it's a physics thing. V sub naught as in the initial velocity. Is there anything else we know? In the directions, did they give us some sort of equation for number 96 that we should be using? Oh, if you guys didn't read the directions and write this down, you would have been sunk before you started. Plus V sub 0 t plus S sub 0. So question, what's V sub 0? The initial velocity, good. What's S sub 0? Where or what height it's starting from. Perfect. Now double check your units. Is everything seeming to work out? Are we measuring in seconds and it's per second? Are we talking about feet and it's feet per second? Yeah, as far as I can tell. Seems to be matching up. What's letter A asking for in 96? Oh, it's not. It's not. Sorry, there's not an A, B, or C, right? My apologies. The first question that was asked in number 96, you tell me. You're the ones that wrote it down already. Do you see why I can just take what you just said, all those words, and say, hey, what's V of 3? What's velocity after 3 seconds, yeah? Wait, who is velocity? Not that guy. They're not the same letter. Ah, it's the derivative of position. So all you do is find S prime and plug in T of 3. Okay, so what's the derivative? Bring down the 2. What do I have? Negative 32 times T, but I'm plugging in a 3. And then minus 22 times nobody, because the derivative, if you guys need to write it out ahead of time. And why does that just disappear? Derivative of any constant is 0. Plug and chug. Double check that your answer is right. You should get whatever the answer was that was on the screen a second ago. And what are you measuring this in? Feet per second. I'm going to be lazy and stick it to the man and pretend like it's a long answer, not a multiple choice, and say, I won't make it wrong. I'll just stop there. Yes, that's a thing. Only for long answer, though. But there was another part to the question, right?
Yeah. What is velocity after 180 feet?
Well, did I leave it unfinished? That's a numerical representation of exactly what it is. Talk to any AP teacher with a good passing rate, and they've drilled their kids to never simplify mental math in a long answer problem. Never, 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 never. There was another question. What was the other question going on? Can I plug feet in for time? Mm-mm. Feet and time aren't the same thing. So I need velocity when, wait a minute, what measures feet? Not T, that's seconds, not V, that's feet per second, but S. Now, why am I going to set S equal to 112 and not 108? Because it says how far it's fallen, not how far it is off the... Look, what does S measure? Is it how far it's fallen or where its current position is? Current position with regards to the ground. If the ground position is 0 and the building position is 220 and it's fallen 108, what position is it at? 112. Or you can think about it, 220 minus. So what do I plug into T? I don't know. What do I plug into S? Oh. I plug in 112, but I don't plug it into T. It's not a time, remember? But what is it? If I can figure out when the position is 112, wouldn't that be the same thing as when I'm supposed to be finding my velocity? I need a when, and I can't find a when from the wording they gave me. It was a where. I can't find the when from anywhere else in the problem, so the only place I can find a when is setting the position equal to 112. How would you do that? It's going to be a little messy, because we're going to get everything to one side. I mean, we could try to factor out stuff. Is it a pretty one, or is it a gross one? We can't pull out 4. We can pull out a 2. We can pull out a -2. That's kind of gross, though. We end up with 8t squared plus 11t minus 54. We have to think of factors of, ultimately, modified x method like Mr. Che taught you, 8 times 54, which would be 2 and 3, 432. That add to be 11. Definitely not 1 or 2 or 10 or 12. Let's see, 100 would be 4-ish. I need to do something smaller than 100. 50-ish would be 6-ish. So that wouldn't be bad. Okay, around 50 that goes in. Does 11 go in? I don't think so. 33, and then that would end up being 102. 11 doesn't go in. Does 12 go in? That'd be 36 and 72. 12 goes in. Ooh, how many times does 12 go in? 36, that would be 3. And then 6. Is it actually 36 times? Ugh, look, that's so close. I mean, kind of, it's 24. Bummer, we need something a little bit higher. 16 might be a good idea. 16 times 27? Go, team. 16 and 27, that works. So then doing guess and check, just because I'm lazy and don't want to do grouping, we could split this up to be -16t and 27t and then do grouping. We will end up with, let's see, that needs to be a 9, and a 9 needs to go with a 3. How is that going to work? Ugh, I better do grouping. My guess and check is not going to be very happy on this one. So that'd be 8t squared minus 16t plus 20 minus 50. Well, that's not bad. So I can pull out a 27, t minus 2. I can pull out an 8t, which would be t minus 2. So that would be -2, 8t plus 27t minus 2. I'm trying to find the zeros of this, right? Because I got everything to one side, like a good math student would. So t is equal to -27/8 or 2. Which time will I use? Yeah, the positive one, not the negative one. What was going on with the negative one? I don't know. The dude was still holding the rock. Maybe he wasn't even up in the building yet. Maybe he was still getting up there. So what do I need to find? V of 2. How? Plugging and chugging to the velocity formula, which is -32 times 2 minus 22? Is that what's going on? Anyway, at this point, I think we at least have the idea of what's supposed to be happening. Let's go back to the answer and say, hey, they set position equal to 112. They figured out the times, the positive time where that happened. They plugged into velocity, and they got -86 feet per second. Whew. What was going on in number 98? Same formula, except this time it's -4.9. P.S. This stuff is being measured in meters, not feet, so a little bit of dimensional analysis could get you the exact same formula. But on number 98, what do they tell you? A stone is dropped. What's the initial velocity if a stone is dropped? So guess what happens in the answer key when they go to actually solving number 98? V sub naught disappeared because dropped. Don't ask me. I don't know what's going on. Yep, no idea. Oh. Okay, as we look at the equation, what happened to the V sub naught? Because, what happened to the S sub naught? Nothing, because they didn't tell me how high the thingamabob was, did they? What do they tell me? The splash is seen 5.6 seconds after the stone is dropped. We know the time when the position, what makes it go splash? It makes contact with the ground or the water, which is at the ground height of water that's at the ground level. So what can I make position equal to? When it hits the ground, position is 0. I don't know S sub naught, but I do know how long it took. Plug in 5.6 seconds. Solve for S sub naught. You'll pretty quickly get 153.7 meters. Splash was when it hit the ground when position was 0, and you plugged in time and got the initial position. 0.664. Oh, this one's 0.664. Yeah. And then number 102. I actually think 102 is basically the trickiest problem of all of homework. In some ways. In some ways. Looking at the graph of 102, isn't this a velocity graph, guys? Right? And isn't the velocity 30 and then 0? Do you see it? The velocity is 30 up, and then it's 0 down, and then it's 60 up. Isn't velocity a derivative? Isn't a derivative a slope of a line? If it's constant, the only type of function with a constant slope is a line. So maybe it makes sense why this guy is sloped up, and then it's flat, and then it's sloped even more up, 30 and then 0 and then 60. But my question is, why isn't there 30s and 60s over here? If the slope is 30, wouldn't it be up 30 over 1, up 30 over 1, up 30 over 1? If the slope was 60, wouldn't it be up 60 over 1, up 60 over 1, up 60 over 1? Why is it divided by 60? That's what a lot of people wouldn't have figured out. Because in the velocity graph, it's in miles per hour. And we're supposed to be working with miles and minutes. Oh, dimensional analysis, building bridges to get rid of what we don't want. We would have had to take that 30 miles per hour and multiply by 1 hour over 60 minutes. So to make it a rate that I can work with, the actual slope would be 1/2 mile per minute. And we do the exact same thing with 60 miles per hour in dimensional analysis. I want you guys to see on the board. Can you see a slope of 1/2 and a slope of 1? Because I see it for that time interval, 0 to 4, going up 1 over 2, up 1 over 2, or up 1 over 1, up 1 over 1. So we had to do a little bit of dimensional analysis to actually get the numbers right. And a lot of you guys might have just kind of not thought about that. Guys, do we have any odds where we're still stuck? 99, 93, 95. Okay, let's do this just because I don't have pictures of the books and of the problem, the book and the problem because it's not working for me online today. Let me get some pictures of those for tomorrow, 93, 95, 99, and then we can look at it a lot quicker and a lot more efficiently. But do you think maybe now that we did 96, 95 might make a little more sense? Maybe. Maybe. 93. Check the video on 89. Maybe. Maybe, but we will talk about those tomorrow. For right now, I want us to get a little bit of notes down, just so that we can say that we started section 2.3. Which the nice thing is, this isn't brand new. In the summer packet, didn't we talk about a product rule and a quotient rule? A product rule and a quotient rule? There are 3 different ways to think about the product rule. We're not going to get to the quotient rule today. You're welcome. But first of all, before we even talk about the product rule, how could we have done this derivative using the basic rules only? This could have totally been a homework problem in section 2.2a. How could you have used the basic rules? Yeah, you would have had to FOIL first. You would have had to rewrite and done d dx of 6x cubed minus 14x squared plus 3x minus 7. We could have totally done this with basic rules. We just would have had to rewrite first, and then we could have gotten our derivative to be 18x squared minus 28x. Now here's the crazy thing. Crazy, that sounded weird. Even though this product could be changed, could be multiplied to make a sum or difference and be solved with the basic rule, not every product can be solved with basic rules. So this one can, and we're going to see how it does work a little bit better tomorrow as we practice the product rule. This one does work with basic rules, but not everyone does. So we're going to talk about the product rule, and the product rule says there are a few different variations, but the one that I'm going to use is when you have the derivative d dx of an f times a g, not a plus, not a minus. The derivative shortcut rule ends up being second, rewriting the second function, d first, taking the derivative of the first function, plus first, rewriting the first function, d second, derivative of the second function. In words, we could say the second function of the product times the derivative of the first, or first prime, plus the first function rewritten times the derivative of the second. Or if you work better with shapes, we could actually take any product and say, hey, u first function could be a square, u second function could be a triangle. And we could actually talk about how this rule could be second triangle d first times box prime plus box times triangle prime. 3 representations of the exact same rule. Some people do, but some people love the actual geometric shapes. Now, as you guys listen to the announcement, I'll show you how it works over here.
Hey Warriors, tomorrow night, Thursday, September 27th, from 6:30 to 8:30 p.m., there will be a worship night. Come out to the senior patio for some amazing fellowship and worship. See you there. She sounds so tired.
Here's my question. Did I do the product rule correctly? Second, d first. What's the derivative? 4x plus 0. Plus, first, rewrite, d second. Here's the question. Are these the same?
Yeah. Yes.
I guess we'll figure out tomorrow. Bye, cool kids.
It is correct. Abby, I need you to wait. I need to tell you a story.
Yes, it is correct.
I checked my web and I never tried to save.